Hello students, let us begin with thermodynamics. You have already written down the definitions of thermodynamics and the different types of systems. I'm sure those were quite simple to understand and you have understood. Now let us begin with the derivation of the first law. Now first law, as it says, energy can neither be created nor destroyed. Based on this principle, we derive the mathematical form of thermodynamics. That is the first law. If we assume that U1 is the initial internal energy of a system, now what we mean by internal energy, you know that whenever you have anything in a system, it has various kinds of energy, such as it has potential energy, it might have heat energy, and if the molecules are at constant random motion, they have kinetic energy, and the kinetic energy also can be of various types. If the molecules are moving in a straight line, that is called translational energy. Then if they are vibrating, then they have vibrational energy. So whatever it is, we do not really know how many molecules are possessing what kind of energy, but total energy of the system initially is considered to be U1. Now since we are talking about thermodynamics, you can understand we are talking about heat gain and heat loss. Now if you are heating a system, let Q be the amount of heat absorbed by the system. That means you are supplying heat. And when you are heating, some amount of work can be done, and that is work done on the system. Now after you perform all these things, you heat the system, you do some kind of work, then what will happen? The internal energy of the system will change. Let the new internal energy or the final internal energy be U2. Now according to first law of thermodynamics, you know that U2 should be equal to U1, which was the initial internal energy, plus Q, that is the amount of heat absorbed, plus W, that is the amount of work done on the system. Now when we bring all the U terms together, it becomes U2 minus U1 equal to Q plus W. Now difference in U2 and U1 is written in the form of delta U, which is Q plus W. That is the first form of first law of thermodynamics. That is, change in internal energy is nothing but sum of the energy absorbed by the system and work done on the system. Now we have some sign conventions regarding Q and W, and very important for you to know. Now sign convention, if work is positive, we consider work to be positive if work is done on the system, and it is negative if work is done by the system. Okay. Now if you see, when you are cooking in a pressure cooker, after heating, the whistle of the pressure cooker rises up. That means work is done by the system. In that case, the sign of the work will be considered to be negative. However, when we are stirring while heating, then our muscular energy is being transferred to the system, and that can be considered as work done on the system. Similarly, when you are heating, heat will be absorbed by the system, and that is considered to be positive. However, when heat is given by the system, given away by the system, that is an exothermic process, heat is considered to be negative. So remember, for exothermic processes, Q is considered to be negative. For endothermic processes, Q is considered to be positive. So based on this, let us work out a simple numerical. A system does work. Be very careful when you read. It says a system does work. That means work is done by the system, equal to 100 joules, and absorbs 300 joules of heat. So find out internal energy change. So what is given to you here? Work is done by the system, so W. Now since it is by the system, the sign of W will be minus, so we write minus 400 joules. Then we know how much is the heat absorbed, Q. Q will be plus 300 joules because heat has been absorbed by the system, that is an endothermic process. So Q is positive. Now apply the formula of first law of thermodynamics, that is delta U is equal to Q plus W. Put the appropriate values with their appropriate sign. That's how you get the answer. Now you note, if there is no internal energy change, that is for an isolated system. You know what is isolated system? Where no heat and matter is allowed to leave or enter the system. Such a system is called isolated system. In that case, delta U is 0. That means there is no change in the internal energy. U2 remains same as U1. Then we replace this value of delta U to be 0 in this equation, and we find Q plus W is equal to 0. Therefore, Q becomes minus W. So that is the first condition we learned. Second, if the system involves a gas, then W is equal to minus P delta V. That means, you know that gases, they are very much related to volume of the gases, are very much dependent on temperature. So either whenever we heat, the volume expands, and if we cool, the volume becomes less. So P delta V will be product of pressure and difference in volume. Now most of the work is considered to be irreversible, so we write WERR, and which is equal to minus P delta V. So in this equation, when we replace the value of W, we get another form of first law, that is delta U is equal to Q minus P delta V. Now depending on the given data, we have to choose the appropriate formula. Should we use Q is equal to delta U is equal to Q plus W, or delta U is equal to Q minus P delta V. Now remember, this work is irreversible work. If the process is carried out at constant volume, that means there is no change in volume, then delta V will be 0. Delta V is nothing but V2 minus V1. That means final volume minus initial volume. Now if both the volumes are same, then the difference will be 0. In that case, if delta V is 0, then what happens to the equation? This equation, what happens? Sorry, not this equation, which equation? Equation number 3. Equation number 3 becomes delta U is equal to Q minus P into 0, and you know anything multiplied by 0 is 0. So it becomes delta U is equal to QV. Why do we write V here? Because we have considered the process is occurring at constant volume. Whenever anything is occurring at constant volume, we call the process isochoric process. Okay, so please try to remember this formulae, and whenever needed they have to be applied. Now remember, W equal to minus P delta V, when we consider the work is irreversible. That means whatever we have done, we cannot reverse it. But if we carry out anything very slowly, we use a term called infinitesimally slowly, then the work can be reversed, and that is called reversible work. Now when the work is reversible, then the formula no longer remains P delta V. It becomes W reversible is equal to minus 2.303 nRT log of V2 by V1. Now what does these symbols mean? N, as you know, is number of moles. R is equal to universal gas constant. T is temperature in Kelvin scale. V2 is the final volume, and V1 is the initial volume. We shall be working out numericals based on these also. Next, let us work out a numerical. Calculate the maximum work obtained. That means you need to calculate W when 0.75 mole of an ideal gas expands isothermally and reversibly at 27 degrees Celsius from 15 liters to 25 liters. So what is given to you? 15 liters is the initial volume. 25 liters is equal to final volume. So you know what is V1 and what is V2. Temperature is given 27 degrees Celsius, which has to be converted to Kelvin scale by adding 273. You know that is the conversion factor. So temperature is becoming 300 Kelvin. Number of moles is given in the question, that is 0.75 mole. Value of R you are expected to know, 8.314 joule per Kelvin per mole. So now we use the formula W reversible is equal to minus 2.303 nRT log of V2 by V1. So all the values being known, N is 0.75, R is 8.314, T is 300, V2 is 25, V1 is 15. We shall be able to calculate reversible work. Now since V2 is more than V1 means work done by the system. So hence the W reversible is coming out to be negative. Next, two homeworks you are supposed to do. A gas expands under constant pressure of 1 atmosphere from 12 liters to 32 liters. So 12 liters will be V1, 32 liters will be V2. When a system absorbs 400 joules of heat, that means Q is 400. What will be the sign that you need to decide? Find the heat change at constant volume. So you have to find out delta U, remember constant volume. So which formula to be applied, you find out accordingly. Next question, 10.0 gram of helium is compressed. Compressed means you are reducing the volume by pressing it. So you can understand work is done by you, that means on the system. Compressed reversibly from 1 atmosphere to 5 atmosphere at 27 degrees Celsius. Find the work done. So please remember, when we use in terms of pressure, then the volume, this formula instead of V2 by V1 it becomes P2 by P1 and the symbol out here becomes positive. That is the only change. Then methane expands at constant pressure of 10 atmosphere from 12 liters to 22 liters. If heat lost to the surrounding is 1000 joule, find the internal energy change. So which formula you have to use here? Delta U is equal to Q minus P delta V. That formula you have to use. Q will be the heat is lost, that means it is an exothermic process. So 1000 joule will be negative. Sign of the heat will be negative, and the gas is expanding, so work is done by the system. So work is done by the system means that also will be negative. You please work it out, these two numericals, and let's see what answer you get. Okay, then next topic will be enthalpy, which will be covered in the next video. Thank you.